my talk is more about like doing SSR on the edge, but I wanted to keep my talk much more beginner friendly. So can you guys tell me like how many people here have worked with SSR before? Okay, how many people here have never heard about SSR? Cool, there's quite a few hands. Great. So I structure the talk in such a way that it will be useful for everybody, even if you know SSR or if you're first time looking at SSR as a concept. So before we get started, let me like talk about the second half of this title, which is what is this edge? So edge, as modern and trendy as it sounds, it's basically like a bunch of servers that are distributed across the world. So to simply put, servers that are hosted very close to our users. So we are already like familiar with such servers. Basically, all the CDNs that we use for putting any of our static assets, rendering our websites, they are all basically the edge locations. So if I am in India, like I just want to like make any contact, for example, let's say I'm going to rippling.com. So usually if it is hosted in a CDN, there will be a copy of that website and its assets hosted on a location that is like very close to India, preferably in Mumbai. And these CDNs are pretty important, especially when you are like building websites for like some very important high velocity e-commerce or like content rich websites. Let me show you why these edge locations are like super important. So this is basically a table that explains the latency of your entire worldwide internet. So basically what happens is, let me zoom in a bit. So let's look at our closest region, Asia Pacific, Mumbai. So what happens here is, while you are in Mumbai, okay, whenever you make any network request through any website, which is like hosted on different server around the world, it usually takes a certain time for the request to actually travel the world. It has to go across like different countries, gateways. It has to hop over different servers to reach the destination. And there is a latency that is involved, regardless of how fast your internet bandwidth is. This is actually the travel time. It's basically like limited by the physics right now. So if you look at it, all the Asia Pacific regions will be having like much better performance. They will be like close to sub 100 milliseconds. But as you move further away, you have all the European regions and you have all the US regions, where when you are looking at Mumbai, it usually like takes close to like 300 milliseconds to reach. So regardless of like how fast or how optimized your website is, the users will always have a 300 milliseconds delay from the time they clicked on a link to the first render of the page that appears. So this is why edge locations are like super important, and we have been using it for like pretty long time, like close to like 20 years. Ever since like e-commerce became a thing, we have been using this edge locations, and they are primarily used in CDNs because it's easy to host CDNs on the edge, because CDNs are usually like serving some static files, content that doesn't change often. And even if you have to change, what will happen is if you use create react app or use some framework to build an application, you will see that all the JavaScript files it generates will have like some random number at the end. So it will be like webpack hyphen some random number.js. So these files are generated with a random number because whenever you upload to a CDN, right, CDN doesn't have to worry about the previous file. It just needs to like put the new file in the place. And whenever a user comes, our HTML will say like, go to this JavaScript file with this random number, and the browser will make that request. So CDNs are like extremely dumb. They just serve the files, but they serve it very, very fast. Whenever you upload a file to a CDN, it sends the copy to every single location in this table. So make sure regardless of where the user is, they will get at least like less than 100 milliseconds latency. Okay, now let's see how this connects to our talk. Now let's look at what is SSR. So I'm pretty sure like many of everyone here has built a website, correct? React, Vue, plain HTML, regardless, everyone would have had their experience building a website. And whenever you are building a website, okay, especially in React, it's pretty common these days to build a single page application, SPS. Can someone tell me what's an SPA? What would you call a single page application? Any volunteers? Yeah. Yeah. Thanks a lot. So pretty much the way SPAs work, right? At any given time, it only loads a single page. Okay, the user will come to your browser, it will load a single page and the page will be displayed. And whenever I am clicking on any other links, it doesn't actually load anything else. It already has all the remaining pages in memory. To show this, I actually built like apps. I built a same app in like different rendering patterns to show you guys how it works. So this is a simple React app that I built using White. Okay, and this is basically how you build a SPA React app. So you have like a app component. Let me like zoom in also over there. Yeah, you will have an app component and you have like a path mentioned here that says in the root render this component when the user is going to a path with some dynamic route, render another component. And basically like the components just make like one API call and they render a corresponding JSX, which is styled using Tailwind. So what I also did is I built one small API. So this API is built with Node.js. It's right now hosted in like Washington, DC, US. I just made sure I put it in a region that is like very far away. Now this API basically gives some lorem ipsum text whenever I go to that API. So let me go to API / lorem. Okay, it generates an array of lorem ipsum text. It basically like gives this text. What I'm going to do is I'm going to use my single page app to make an API call and load this text on the screen. So let me just go over to that app. So it's like fully rendered on the client side. Let me do a cold refresh. So right now that API is built using serverless. I'll explain that concept as well. So now I'm doing a full hard refresh. You will see first it renders the JavaScript and the client side page, and it rendered the content because I wrote the code in use effect. So the way it actually loads is that it has to like first render this DOM element fully, then use effect will run, and this use effect will take this URL and basically like renders the data. This is pretty much how we started building apps in React. Anybody who started building apps in React, this could have been the go-to approach. And this is like fetch, this is render and then fetch pattern on CSA itself. So basically what happens is first rendering will happen, then the fetch calls will fire. This is actually a pretty big problem in many SPAs because React team has been like trying to push suspense forward, which says render as you fetch, so that API calls will happen much faster instead of having to like wait till the entire DOM has been rendered. Cool. Now let's take a look at the dev tool as well to see what's going on behind the scenes as I am like making this request. And I also made sure this is like a pure single page app. I had like zero server side logic on this. I'll also show you guys the effect of that. So now let's look at the network tab. Let me zoom in the text. Okay. Here you have the JS tab active, which means it can show all the JavaScript assets it has to load while the page is like rendering. So let me do a quick refresh. Let me do a hard refresh. Cool. I think I turned off code splitting or something because it usually loads much more JavaScript files. But cool. I think it doesn't have code splitting because I actually moved everything into a single file. So it pretty much rendered the entire JavaScript bundle as a single file. So basically it has to like load this 45 KB of JavaScript every request. And if this JavaScript doesn't load, the page itself will not render because the way we build React apps is that we have this index.html file. And in this index.html file, we declare like one div as an interactive div called root. And we tell React to like mount to that root. So what will happen in main.js is I'll say, once you find the root element, append your React DOM over that. So this worked because it came with a lot of advantages for the developers. So let me get back to the slides. So this is client side rendering, and it is like really great because at the end of the day, what you have is you have only full static files. Correct. So you just need to like push them into a CDN and your hosting problem is done. And once the page has been like fully loaded, okay, if I have to like navigate anywhere within that page, if I have to navigate anywhere, for example, I have put some navigation over here. If I click on read more, it will load in immediately. The page transition will happen immediately. I did put a pretty slow API call over there for the content, but the page transition are smooth. Users will see that it is not reloading the entire page. Whatever is static immediately like switches over. So this is great. And of course, this is why React actually became really popular, because it also gave developers a great experience, because as you are like writing and building it does a hot reload, you get to see the changes immediately. There is like little hiccups with SEO, but however, the modern crawlers have been updated to actually wait for certain client-side rendered code also to run. So these days, even if you have like a pure client-side rendered app, some Google's SEO crawlers are all going good, but it has a lot of hiccups around SEO. Then finally, it is hostable on the edge, which means regardless of where your customer is, the first render latency is good. However, it's also not say great, because the initial page load will always lead to a layout shift. So that is basically like what we have been like facing here. Every time I am like doing a refresh, it renders one part of the layout first, and it renders the second half of the layout once the API call has been completed. This layout shift leads to like pretty bad user experience for like any user. You can try solving it on the client side by doing like SWR or render as you fetch. There are like multiple solutions and applications available to solve this problem, but I'm just gonna go with a much more simpler approach than like going into all of those details. But yeah, the layout shift is like prominent. Whenever I switch a page, whatever content that needs like data to be loaded, they often like take certain time. They need like a small step. So user will always see, okay, the page is like always moving around a lot. It's pretty bad. Whenever you're like building an application, you should reduce the layout shift as much as possible. Then there is like a very bad cold start time involved, which means since the page has to wait for all the JavaScript bundles to load, when the user is coming to the page for the very first time, there is always a cold start, which means my page, I did a small benchmark. It took like a few 100 milliseconds because it's just a single page application. But as your application grows and you have like a SPA, the amount of JS payload pretty much determines how fast your site becomes interactive. Now there are like different solutions for this. Client side is not the only cause of this problem, but this is more prominent on the client side rendered apps. So some solutions will be like in the last talk, the previous person was also saying, you have to like you have to split your code. This concept is called code splitting. You have to make sure you split your JavaScript files and load the minimum amount of JavaScript needed for the page to become interactive. The goal is to like make sure the cold start of your website is like very, very less. When the user is coming for the first time, they should get the website as interactive as possible, as fast as possible. Okay, and eventually as your SPA grows, you keep adding more and more React components. This is a problem that I face with like every team that I have worked with. There will be like hundreds of components running in a single page. It tends to like overload the browser. So Preact team did like excellent research when they were building signals. So I can also show you that blog post. So this is what they found. So that is that half basically like shows how the page renders with virtual DOM and how Preact team went on to optimize the whole JS thread problems. So virtual DOM is fast, but it actually can be much, much faster. We have much faster solutions right now, like Solid JS, which basically like does direct value manipulation. So Preact basically like took that approach and started optimizing the VDOM, and they released a excellent library called Signals, which is like states, but on steroids. You put a signal in, it doesn't cause any re-render in your component. Think about it. Your component actually won't re-render, but the UI will change as you are like updating signals. This could be a topic for another day, but yeah, as your single page application is like growing a lot, you often tend to like run into a problem just by having like too much JavaScript. the browser thread starts to get really, really busy. Now, there are many ways to solve these problems. I'm not telling you the only way. I'm just giving you guys a approach that really worked well. Now, introducing server-side rendering. Okay. Now, the whole idea behind server-side rendering is that why are we overloading the users' browsers all the time to do everything? Correct. Browsers are getting faster. That is cool. But at any given point of time, users tend to have like hundreds of tabs open. And imagine like hundreds of tabs running like heavyweight single page applications in all 100 tabs. This is when you start noticing, like if you had like multiple Facebook tabs or multiple YouTube tabs, you will start seeing that the browser starts performing slowly. But at the same time, if you have like multiple tabs of like some static news websites or something, you won't actually see that much of performance degradation. So now what server-side rendering does is it offloads some of the work over to the server. And there are like different ways to get that work offloaded to the server. Cool. So first one I'm going to explain is a much simpler thing. It's called static site generation. So let's look at my current application, which is like built on the client side fully right now. It's an application that has like some 50 blog posts, 57 blog posts. Cool. And all these 57 blog posts are being loaded from an API. Okay. And every time I move over a page, it still makes another call to the API to get the 20th blog post. So technically, if I step back and think about it, I already know this page is actually going to have 58 blog posts. Okay. So this is where static site generation, what it explains is, instead of having to like build a complex client-side application to display these 58 blog posts, what you can do is you can generate 58 different HTML files, put it in an S3 bucket, and you are technically done. Correct? You generate all these files on the server, you host it there, and it will be like plain HTML, and your users will have very good performance. So I actually went with a framework that does SSD really well. So this is my SSD app code. So I built this page using this framework called Astro. So Astro is like one of the new frameworks. It's like really good. I highly recommend you guys to try it out. It can do all forms of server rendering. Now I'm using it for doing SSD. So what this framework does is, this is like my index page. If you look at the file name, it's index.astro. This is the root page. Basically, I have like two sections in this file. It's the extension itself is called .astro. It's just JavaScript and HTML together on the same file. But unlike React, this is like on a completely different scale. So what happens is, if you see the code that is written in between these two lines, this code will run on the server. And anything that is like written after the two lines, it will be like converted into a string and will be delivered to the browser. So now what happens is, I am making the API call on the top line on the request, and another interesting thing, I'm using await without a async function. This is called top level await. Astro has managed to like make it a reality. So kudos to the Astro team. So I get a top level await and I got the data, and I basically like have like some React kind of syntax here that basically like iterates over the data and generates the content. And I also have another special page called ID inside brackets. So this page's role is basically like generate all the dynamic pages from the blog data. So I get the blog data here, and I basically map over that, and I give each page a param, which is basically the index of the blog post. Then what I do is I'll take that index and tell Astro, for whatever index you find, generate the blog post with the corresponding index. So now what happens once I do that? Let me show you directly in the GitHub repo itself. Cool. So this is a GitHub action that I used to like deploy that page. During the build step, what Astro will do is it will run a build and it will generate the artifacts. And if you look at the artifacts, it's basically like 58 different HTML files with every single blog post. So now, if I actually go and visit this page, I can go and visit this page, and the same page, same content, but generated statically. Now let me do a hard refresh. Actually, it refreshed. Basically, there is like literally zero layout shift, and you guys are actually seeing the content without any form of like jittering or anything. And here is the best part. I can like inspect this page. I can click on network, same JavaScript tag. I can do a hard refresh, and there is like no layout shift, no JavaScript file loaded, but you get the same page with all the functionalities half loaded to the server. Cool. Now, if I click read more, I can go to the next page, and I can be smart. I can even preload all of these pages. So this actually performs much faster than a single page application. So far, the tooling behind this has been like little hard because previously we had Gatsby, then Next.js. They all did SSD, but they also loaded like heavy JavaScript payload, even when the page was like rendered with SSD. But now Astro has been like completely revamped to deliver zero JavaScript so that the page will be fast regardless of how many content wise how big your project scales. Now, I actually like forgot to show you guys something in the client side rendered app. So also, if you look at the URL, whenever I'm like switching page, it actually displays the post ID on the URL. If I do a refresh, it will simply say the page not found in the single page app. This is because the navigation also happens through the JavaScript. Unless you have a logic on the server to handle the refresh, the single page applications cannot handle refresh on their own. They will work only when you are like navigating through the app. This is why you need those tools like React Router, all of those things. Cool. Now, let's look at the advantages we got. So SSG is really great if your website is like filled with content. Like you have like FAQ pages, blog pages, static documentations. Pretty much everything is like built on this SSD pattern, like the whole Jamstack ecosystem. And you get like extremely good SEO because the crawlers doesn't need to like parse any JavaScript or make any external API calls because all the content is always available as a single HTML, the way websites are designed to like work. And they also tend to be very reliable because there is no server logic or like client logic. Once you know the site has been generated, you can guarantee it will work the same for every single users. And finally, the same advantage as the SPA, you get the page to be hosted on the edge, which means it will be very close to the user. And you guys saw I did a command shift R, which is a cold refresh. You literally saw zero layout shift. That is how good SSD pages can become. Cool. There is still like one small downside with SSD. When your content is dynamic, okay, you immediately start losing all of these advantages. Say that you have like a blog post, okay, and you have like a user who is logged in, and for some reason you have to display the user's name inside that blog post. Correct, which means there is some dynamic interaction needed on that page. So you might have to like figure out something to do on the client side, or you will have to use this another version of server side rendering. Cool. So now we'll go to the other version of server side rendering, which is basically like the normal SSR pattern that you guys might be hearing about all this time. So the first thing about SSR is just like SSG, it has to like generate the HTML file. But however, in SSD, what I did is I generated all the HTML files and stored it on a normal GitHub CDN. But here I cannot do it on the CDN. Instead, what happens is whenever I make a request, a Node.js server will run and it will generate the HTML on the fly. Cool. So the first HTML is always rendered on the server. And the second, once the rendering is finished, it will also send the JavaScript payload and everything else needed to like for the user to do further interaction on the browser. So now what will happen is the client will take over the control. So what happens is when the user is coming for the first time, the first hit usually will be full SSR'd, which means server will run the logic, send a pre-generated HTML file. So the client will render the file without any jitter or like layout shift, just like how SSDs work. But once the client starts interacting around, now it starts behaving like a single page application. It has like client side routing. It takes, does all the things that happens on the client side. But now you have the problem with client-side routing, the layout shift problem and the SEO problem solved. Because if a crawler comes to visit that site, it gets the full HTML. But the crawler doesn't usually do single page navigation. The crawler will load successive pages through URL. So you get good SEO. And you also, there is still some trade-offs. Let me first show you the SSR app that I built. Now this SSR app I built with Next.js. Pretty sure it's like the cool framework out there. It came out like top on all the recent surveys. So now this is my index file. This is the home page of the SSR site. Now, if you see, it renders like one React component called home that gets the data. However, to get the data, what I have done here is at the bottom, remember I'm not using use effect here because I'm going to make the API call from the server directly. So now what happens is I have this function called get server side props. It makes the API call using fetch. So on the server side, it will make the API call, it will get the data, and it will return the data under an argument called props. And that prop will be used for this home page. Now what will happen? On the server itself, there is a method available inside React that can construct the HTML on the server as a string. Okay, it will go through this component, apply the data wherever we have asked for, and generates a full HTML string, renders the string for the users. And not only that, it will also send the React file and every JavaScript file needed for the page to perform as a single page application as well. Now let me show you guys how this SSR app runs. So this SSR app is also hosted in the Washington region. Let me do a cold refresh. And it's still reloading. Yeah, so the reload is done. And you guys see, there is no layout shift. You get the same first render, like how it happened, like in the normal SST pattern. Now, I can click read more, and this will actually navigate without reloading the page, just like a single page application. Now, in the previous single page application, if I did a refresh, it simply said page not found because there is no server side logic. But here, if I do a refresh, if I do a command shift or, it will reload, and it actually reloaded and displayed the page. So now already you guys are seeing, I can run dynamic logic because I'm using like fetch, all this dynamic stuff on the server side, and I am constructing and sending the HTML over, and it performs almost like an SSD app. One part of the problem solved. Now let's have like a small deep dive into what other challenges that are here. So SSR is not like a foolproof solution like any other solution. Usually whenever you are like applying or looking for a solution to a problem, there will be like both plus and minus in every approach. Now the problem with SSR is it needs an active Node.js server. Because let me show you guys where I have like hosted my SSR page. Yeah, so this is where I have like hosted my SSR page, and unlike the last page, it's not HTML, but instead I have like a Node.js server running in Washington, and both of my page URLs, both index and the dynamic ID, are present here as like two different Node.js functions. So it needs an active Node.js server. Second, large traffic, which means you have to treat your front end just like how you treat your back end. It needs to scale, it needs to have that auto scaling option, Kubernetes, all of that. Or better, you can also go serverless. Third, the Node.js server can't be put on the edge easily because now it's no longer like static content. It's a live server. You have to like host the server manually. If you are hosting it in AWS, you have to host it in like every single region. And you also make sure every time you are like pushing updates, you have to like push updates to every single region, and your server cost will also like start to rise. So what we did is, this is a scaling problem. Like number of traffic will lead to your actual website going down. It's very, very risky, especially the front end part, because it will simply say on the browser that a website is not reachable. So what we did is, this solution came in partway. Whenever there's an SSR page involved, we started scaling it with serverless. Serverless do. How many people here know the concept of serverless? Okay, I'm seeing like quite a few hands. For all the people who don't know what serverless means, instead of like running all your code together in a single machine, single EC2 instance, what serverless approach does is take any single piece of code that you write, it turns all of those code into like individual functions and basically deploys each function individually in a container. You can technically like make one API call to that function and get the response back. And whenever like 10 different requests come for that API, the server will spin up 10 different instances. So all 10 requests gets resolved at the same time, which means your website can have like 100 users, 1000 users, even a million users. Theoretically, there won't be any delay because for 1 million requests, 1 million new instances will be spinned up and they will be processing this request separately. So even the current server that I have in Vercel, it also is a serverless function, which basically means both pages have like two different functions. So the index page is a separate function. The ID page, which generates a dynamic blog, that's also a different separate function. Now, this serverless is really great because at scale, you can have, as your volume grows, serverless is much cheaper than hosting a full-fledged server in EC2. This is because only the required resources will be consumed. Say that over the weekends, no one is actually using your product. It's like a product focused on businesses. You will literally not be billed for the weekends because no one is invoking those serverless functions. But at the same time, say that there is gonna be a pretty high spike in traffic coming in. For example, there's a sale running and people have to like come to your website. You will see your actual cost go up because number of function invocations will be like higher. So this again becomes a whole different topic on its own, how to like build and scale serverless. I'll just leave it to you guys. Just let me know if you want me to like do any of these topics in the future meetups. I'll be like more than happy to do. Now, let's look at the next problem. So serverless node has this problem called a cold start. So when I was telling you about the cold start in the client-side application, a cold start basically means a user is coming to the website for the very first time. Okay, I'm coming to the website for the first time. I have to freshly download all the JavaScript files needed for my application to run. Okay, that takes quite a significant amount of time. Now this cold start problem has been moved from the client to the server, because what happens is these serverless platforms, to save you cost, whenever the functions are not in use, they will just turn off those functions. The functions will go down. Now what happens is if another user is coming, I'm coming to that website for the first time, it has to invoke and put that serverless function into a container and start it. Usually there is like a lot of work going on optimizing that start, but still it takes some 100 milliseconds usually for the server to wake up. This cold start problem is not significant at scale because always some user will be visiting your website and these functions will stay alive for at least 2 hours, even if they are not processing. But if there is like any application that has like significantly less traffic, some users often tend to see this cold start problem happen now and then. Secondly, there is no edge location, which means whenever you're doing an SSR page, again, depends on the region, the performance will start to vary. So what you will have to do is you will have to end up manually like deploying this SSR functions in like several different regions. And Node.js is like has a disadvantage with the edge because Node.js is designed on the system level. It uses system level APIs. It uses file system. It uses like network, TLS, all of those modules, which as web developers, we don't use, but Node.js internally needs to load all of those modules. That is why you got all this cold start. And since it's a system level language, it also serverless platforms have to provision an entire operating system. That is also taking into all the time and the scaling effort. So edge locations in SSR with the node becomes like really hard. Now you guys know where I am actually going, because we got SSG static, which serves data from the edge location really fast. SSR, which does the same performance on the dynamic, but has a problem because the solutions are not running on the edge. Whenever the dynamic content comes into play, we are not able to host it as close as to our users like the static files. Now we finally get to the talk. This is basically I've been like setting the background before coming to the actual topic, which is the edge compute. Okay, so now what happens is, along with the static content, you now get your dynamic content also moving to the edge locations. Okay, so first thing is, how is this possible? How did you suddenly like get an entire Node.js platform to run on very minimal server requirements? Because Node.js is heavy, it has a lot of problems with starting up and down. So now what happened is, there are people who built node-like environments, but it's not Node.js. So it will look like Node.js. You can write Node.js related code. It will behave the same way. But the moment you use any native modules like FS or TLS, it will just throw an error saying module not found. So basically, they just took all of these heavy modules out. Okay, and they made a very lightweight runtime. Okay, technically, we already have one runtime that is in our browser called V8. So they just took that runtime out and hosted it on a server and made it actually become a platform. So now you can run your code on a very lightweight environment and it will run really fast. So right now, our modern runtimes, let me give you some platforms that are actively doing this. So you guys know Dino. So people thought like Dino is a very cool runtime and all, but the really big advantage Dino came with is, it didn't need any of those heavyweight modules. So now they have their own hosting platform called Dino Deploy. How many people heard about Dino Deploy as a platform? Cool. I see like very less number of hands, but how many people would have heard about Dino? I'm pretty sure every Node developer would have heard. But the main idea behind the team is to bring a platform that is like very lightweight to run. Now both Dino Deploy and Netlify functions use this. Basically, whenever you push any JavaScript logic, the code will be sent to all the servers around the world. So there is like some 35 to 40 locations. It will be sent all the 40 locations. And for paid enterprise plans and all, they have like 200, 300 locations. So the code goes all the way. Now users get to like execute logic much fast. Then there is this new framework called Bun, which recently did a fundraising round, and they are building their own platform called Oven. Kudos to the team. They are coming up with some crazy names. Third one, which is my favorite, which is Workerd. You might not heard about this runtime a lot because they were the pioneers who introduced, they figured out, okay, you can take some modules out and actually make JavaScript run faster. Tree shaking. So they did tree shaking on the server side and they built Cloudflare workers, and Vercel piggybacked on the Cloudflare workers, and they also got Vercel edge functions. So now you have a very interesting platform that basically like runs code very close to the user. Now what happens is, suddenly you don't have to write all the logic on your client side and overload the browsers. You can write your logic on these platforms. They will run it close to the users. Only the result will be sent to the user. Now think about how much optimizations your page at the end of the day will get. So only one thing you have to know is that edge environments lack any native APIs like FS, TLS. One funny disadvantage is your edge environment can't connect to many of the currently available databases, which means if you have a Postgres database, your edge environment actually can't connect to a Postgres database. But let me come back to you why it might actually be a bad idea. First, let me show you the app I built. Unfortunately, in my free plan, I can't show you the performance of the edge. I need to upgrade to a paid plan. So I'll just show you the code and also how it works in general. So for this edge, I basically used Next.js 13, which actually like stabilized many of their APIs. Sorry, this is the SSR. Edge SSR. Cool. Now there is the app directory, and we have like one React component called page. And here I'll be proud to introduce you guys a new syntax again, this time from Next.js team. So if you look closely, I get to write await fetch without the use effect. That's like so damn cool. I've been waiting for this ever since React hooks released. So let me tell you how this whole new syntax works. So what the Next.js team thought in their version 13 with their app directory is that, anyway, people are like, if you take any interactive page, okay, most of the content are actually static. Think about it, all the sidebars, your headers, the page backgrounds, most of them are always static. Why are we like unnecessarily running those logic on the client side? So by default, what Next.js does is, from 13, with the app directory, all the logic will always be run on the server side, which means all your component will only run once. Got me? Use effect is needed only when your component needs to like continuously run. This component won't run multiple times unless I specifically say, hey, Next.js, let this component run on the client side using the use client directive. So now this component runs only one time, that too on the server side. I am free to use await all of this asynchronous code without any worries directly inside my page component directly. I could have done it on the previous code also. I just wanted to like try this syntax out. So I just built it for fun. So now you get to have the same page and the page that loads individual IDs. And here is one interesting thing. While I am like making this fetch request on the server side, and I know my server is actually hosted very, very close to the user. Like if the user is making the request from Mumbai, I actually running this logic from Mumbai. I can actually cache this request on Mumbai also. Think about it. I make an API call. The API call has to go to the Washington server that I have to bring the data in. Technically, I can cache this data in the closest region. It will also add to my performance. So now what happens is at the end, I would have set a revalidation time saying for the next 10 seconds, any request comes, just display whatever data you got. After 10 seconds, make one API call to that server, fetch the data, and again, keep the data valid for 10 more seconds. Technically, you can do it for like days, weeks, depending on the type of content you got, even years. And you get to have that edge performance over time. Like as first 2-3 users start using the page with the dynamic content, for the next users, it will start actually behaving like a SST app because all the data has been already brought in and cached. So caching is again a pretty big topic, invalidation strategies, etc., etc. If you guys want, I'll do it as a separate topic. You can like reach out to me after the meet if there are any specific concepts you want to like learn about. Cool. Now I set up this page and everything. Unfortunately, it will look and work just like the SSR page because this is the edge rendered page. If I do a refresh, it pretty much behaves the same way like the SSR page. There won't be any significant changes. But thanks to Next.js, it would have reduced some JavaScript payload and the first latency will be like much, much faster. Cool. And if I go back to the server where I am like hosting this is the edge function. So I got these functions in. So now you see the runtime is set as edge and the region is set as global, which basically means this function is hosted in all the countries they have for their free plan. And you get much, much faster latency as your users are like visiting this page. Now let's go and like take a look at the databases thing. Yeah, so the edge locations actually can't connect to databases. Like there are some databases like CockroachDB, PlanetScale, DynamoDB with their global tables. They are like adopting to support edge locations. But however, it's actually not a good thing for your edge logic to connect to database because databases often will not be distributed, which means your request will end up actually going around the globe just because the database is involved. So it's really better if you like reduce the logic only to things that will actually speed up the content. For example, if you want to like validate your jailbreak token, you want to do localization, if you want to do feature flags, certain things that will be adding value by running on the edge, it's better to keep those specific features on the edge. Databases, you can like always fall back to the previous Node.js based SSR pages whenever a logic that needs to hit the database has to run. It's a balance. You cannot like have one size fits all solution in this rendering pattern. And luckily, I would have like covered 3 rendering patterns here. So client side rendering, server side rendering, static side generation. Just 7 more to cover talks for like other meetup. Okay, if you guys visited the State of JS survey, you would have like noticed there's like 10 different rendering patterns championed by different frameworks. Each has their own pluses and minuses. It's just how we actually learn which rendering pattern is like good for our specific application. So there's like already a lot of studies going on right now. But if you ask me, just generate HTML files. Why overcomplicate stuff? So that concludes my talk. So do you guys have any questions so far?